Hello everyone. I hope you're all doing fine. I would like to welcome you to this other presentation in our series. Okay, on data analysis. We are still dealing with statistical analysis. Okay, and today we will proceed with explanatory factor analysis. Okay, I will start presenting on this very shortly. It will be good if you pay attention, okay? And at the end, during the presentation, excuse me, send us your questions using the Q&A section. And at the end, I will gladly provide answers to all of your questions. And I hope, I think confident that this presentation is going to be very helpful since it addresses an issue that most of our students would be experiencing, especially those who are not using an already validated instrument for their quantitative research. So once again, I welcome you all to this other presentation in this series of data analysis. Okay, I think it's time. So we will start. I'm going to share my screen, okay, and we will proceed with the presentation, after which we will take questions. Okay, okay, good. Okay, perfect. So today we'll be talking about exploratory factor analysis. And before we start, I would just like to highlight what we mean by factor analysis. Okay, generally, factor analysis is seen as a variable reduction technique. And we have two types of factor analysis. We have exploratory factor analysis, and we have confirmatory factor analysis. The next presentation is going to be on confirmatory factor analysis. Okay. For now, we are first of all going to look at exploratory factor analysis. Exploratory factor analysis, when should you make use of it? It's very, very useful. It comes in very handy when you want to conduct a quantitative research and you don't have an already validated instrument that is existing that you can use to evaluate the construct that you want to evaluate. Okay, from the presentations we've been seeing during the RDCs and RGPs, we see many students, and it's very common that in research you want to conduct a quantitative research and you want to evaluate or maybe collect quantitative data on constructs that do not yet have an established scale on how to evaluate them. So when you find yourself in such a situation, okay, the exploratory factor analysis is a good starting point. Okay, and so let's just say you want to conduct an analysis, and you want to measure a construct, and there is no scale existing to measure that construct, and you decide to go to read through the literature. Okay, you read through the literature and you see some of those factors in the literature that have been pointed out to be relevant to the particular construct that you want to measure. Okay, maybe you are carrying out a mixed method research and you maybe use the exploratory sequential design, meaning you've collected data from maybe experts in the field, in the domain, and you've had expert opinions, you've done some key informant interviews and the rest, and you have the opinions of experts in the domain, and you want to proceed with a quantitative research to measure the construct that you want to measure. And so from this secondary data, or from this literature review, or maybe also from the opinions of experts, you've been able to identify certain factors that are very relevant to that particular construct that you want to measure. So how do you proceed? The next thing you want to do is to run an exploratory factor analysis, okay, after collecting data. So this is very good for piloting, okay? After you've collected data using those particular variables that you identified from literature or from expert opinions as relevant to the construct you're measuring. Now you want to make sure that those factors that you've identified all relate well with the quantitative data that you've collected from the ground. So maybe you use those factors, you develop a Likert scale instrument, okay? And then based on those factors, and you want to see which of those factors then best describe that particular construct, okay? Which variables capture the highest, the greatest variability within that construct. And so you need to reduce, so in so doing, you are going to reduce the maybe multiple variables that you had captured from literature, reduce them to classify them into particular groups or particular components, okay? You can, into particular categories, if I can put it that way. And at the same time, identify those variables that you've gotten from the literature review or from expert opinion that do not really describe the construct very much, that are not very meaningful to the construct. So the exploratory factor analysis is a very, very good starting point when you are in this situation. So I think from now henceforth, we will maybe expect students who are developing their own instrument and developing their own questionnaires, maybe doing the piloting of the questionnaire to run an exploratory factor analysis, okay? Or even when it's done, you still run exploratory factor analysis, and you are able to identify the different factors or the different categories that come out from these different variables that you identified, and also eliminate those variables that do not describe your construct very much. Okay, so that's quite a lengthy introduction. Even, some of the things I've already spoken about, I'll come back to them while I'm carrying out this presentation. Okay, good. So let's say I want to identify or maybe get a clear picture of how maybe customers of a bank perceive the quality of the services that they receive. Okay, so I want to evaluate the customers' perception of the quality of the services provided to them by the bank. And let's say there is no service quality instrument, or there is no validated instrument for measuring service quality. But of course, there is an already validated instrument. In fact, there are multiple validated instruments. Well, they all have the same components, the same dimensions, but there already exists a validated instrument for measuring service quality. But let's just say in the event where we don't have an already validated instrument for measuring service quality, and I go through the literature, and maybe the literature points out that customers evaluate service quality based on two aspects, the reliability and also the responsiveness of the bank. Reliability, meaning customers, when the bank says they will do something, they actually do it, okay? So maybe that is perceived by customers as a very important aspect to the quality of the service they are receiving. And also responsiveness. Let's say from the literature, I also identified certain aspects of responsiveness, like for the bank response to customers' issues very, very rapidly. Okay, so let's say I identify those as meaningful aspects, and I then developed an initial questionnaire, and I administered it to participants, collected the data, and entered the data into SPSS. And now I want to run my exploratory factor analysis. As you can see here, I have 1, 2, 3, 4, 7, I have 10 variables, okay? I have 10 variables. And I want to proceed with a factor analysis to reduce those variables or to classify them into components, and also identify those variables that do not properly describe the construct that I am studying. Okay, so once I have my data entered into SPSS, the next thing I do is click on Analyze. Analyze is the go-to place in SPSS. Okay, so that's where you actually run your analysis. And to run my exploratory factor analysis, I will come to dimension reduction. Okay, so I'm actually reducing my variables into maybe dimensions, identifying the dimensions that are relevant to the construct that I'm trying to study. So, and then I click on factor. Okay. Okay, I've already put my variables this way, but let me take them back the other way. Okay, so when you do that, your variables, the variables in the construct that you want to evaluate will be this way. So you have to bring them to this other side. Okay, the first thing we do, we come to descriptives. We come to descriptives. Generally, I think the KMO box and this box, this checkbox, which is the KMO and the Butler's test of sphericity will not be checked, so you have to check this box. And it's also good to check this reproduce box. In fact, here, what we are trying to do here is with these two boxes that we've checked is to evaluate how adequate our sample is, okay, to run exploratory factor analysis. So the KMO and the KMO and the Butler's test of sphericity, I'll come back to them once the results of the analysis are done, and I will provide you with more explanation on what they mean. We also have this also, I'll be providing more explanation on this. Okay, so you want to have these two boxes checked, okay, in the descriptives. Okay, click on continue. We come to extraction. Extraction, yeah, it's good to always have it on principal component analysis, okay? Generally, when we are running exploratory, most of the times when people are running exploratory factor analysis, they generally make use of this principal component analysis, but others also make use of the maximum likelihood and principal factor analysis. That's for other situations. But in our case where you want to test, you want to actually reduce your variables into categories and make sure your instrument is captures the variability as you would like it to, we would recommend principal component analysis. Generally, almost every factor analysis you would see around would choose the option principal component analysis. So we leave it on principal component analysis. Okay. Click on continue. Rotations, this is very, very important. Okay, now is the rotation that will actually group the variables into different categories or dimensions. You are going to see that once the result is out. And we have these options that are here, but generally researchers make use of these two options, the Varimax and the direct oblique option. The Varimax option is used when that is, the different factors of the categories or the different groupings of the variables should not have any correlation between them. Therefore, you should be able to group your variables into distinct factors, okay, into factors that are distinct. Now, for the direct rotation, even when the factors are identified, there is still correlation between them. So if you are in a situation where you want the factors to have some amount of, you suspect some amount of correlation between the factors, then the direct oblique and rotation will be suitable. But if you are in a situation where you actually want to test your instrument, the Varimax option is that which you should use. That's the kind of rotation which you should use. Okay, because you want to categorize your variables or put your variables into different dimensions, categorize them, and those categories should be distinct between them. There should not be correlation between them. Okay, so that you have distinct dimensions that you can use to properly describe the construct or capture the construct that you intend to measure. So I would strongly advise that you use the Varimax option so that those maybe let's call them factors, the factors or the different categories or the different dimensions do not have any correlation between them. Okay, so we click on continue. Some of these things I will explain them much more clearly during once the result of the analysis is done. Okay, then scores, well, nothing to change here. Okay, options. When you come to options, generally what I like to do is that I want to suppress every variable that has a factor loading less than 50% or less than 0.05. Now, a very important thing to keep in mind is that when you are doing factor analysis, most of the core analysis or the root analysis that is being run is correlation analysis. Okay, and the factor loading, which I'm going to explain again later, okay, tells you how well each variable correlates with that particular factor or with a particular category. Okay, we are going to come to that later. But just keep in mind that you want to have variables with factor loadings that are higher than 0.05 because, like I said, the core or the foundation analysis that is being run when you're doing factor analysis is simply correlation. It's just a set of correlation analysis that are run in a very specific order and manner, and then the AI presents you information that, I mean, in a way that is meaningful to your factor analysis. And we know in a correlation analysis, anything 5% and above is a strong is a strong correlation. Okay, so since the factors that we are studying are all measuring the same construct, there should be some correlation between them. Okay, they should be correlating in some way. And if there is really no correlation between them, it means they cannot be measuring the same thing. Okay, just a quick example. Let me say I want to measure how people are satisfied with the service of a bank, and I use multiple questions to evaluate their satisfaction of the services provided by the bank. Anybody who is satisfied by the service of the bank should have high responses for those questions. Okay, person who is not satisfied with the services of the bank should have maybe low or responses to the different questions that I'm asking, because all of those questions are geared towards measuring their level of satisfaction with the services provided by the bank. So there should be some correlation between the responses to the different questions that I've asked, because they are all trying to measure the same thing. Now, if there is no correlation between them, it means those questions are not even adequate for measuring satisfaction of the bank, because if they're actually measuring satisfaction, they should be actually saying the same thing. Okay, or maybe not saying the same thing, but they should be all moving in the same direction. So yeah, so we want to suppress those variables that have correlation, that have factor loading less than 50%. Factor loading is just correlation with the general category. So those with low factor loading, we would eliminate all those variables and will not use them in our construct, because they do not capture much of what we are trying to study. Okay, I hope that explanation was clear. Okay, so once that is done, good. We now click on OK. And once we click on OK, SPSS will run the analysis and will provide us with our results. Okay, good. Now let's take a look at our results. Now, the first box, this one that we have, is actually testing the fitness of our model. It's actually testing how good our sample is for a factor analysis. Is our sample good enough for factor analysis? Now, the Kaiser-Meyer test, or the KMO, what we call the KMO test, okay, should always be should always have values between 0.5, excuse me, and 1. Okay, now if your KMO test has values that are less than 5, it means the sample is not adequate for factor analysis. It means that data set is not adequate for factor analysis. Now, this generally occurs when the sample used for this analysis is too small. Okay, your KMO would be less than 0.5. Okay, it also occurs when you have some, at times when you have some negative correlations between them, and you also have a KMO that might not even be possible to run. Okay. So the first thing you want to ensure is that the sample is adequate. That sample is really a good fit for your exploratory factor analysis. Then the next thing which we want to look at is the Butler's test of sphericity. Okay. What we are interested in here is having a level of significance which is less than 0.05. Okay. When this value is less than 0.05, it means there is correlation between the variables, okay, that are used in the analysis, and which is what we want. Okay, we want that those variables should actually correlate if they are all measuring the same construct. Okay, we want them to actually have some level of correlation. Okay, let me still just use an example to try to explain what I'm saying. Let's say I want to measure the level of satisfaction of UNICAF students with the services provided by UNICAF University, and I ask them a general question: are you satisfied with the services provided by UNICAF University? And they say yes. And I decide to reformulate that question and use other words. Do the services provided by UNICAF University really make you happy? I mean, the answer should not be very different from the first. Okay, it should not be very different from the first, because I mean it's actually the same thing. And I say, okay, but if you want to compare UNICAF University to the quality of services to what you would expect from a university like this one, what would be your level of appreciation? I mean, they should all be moving in the same direction. All of those responses should be correlated, meaning they should be moving in the same direction because they are all trying to evaluate the same thing. Okay, they're all trying to measure the same thing. Okay, so there should be actually some correlation strong correlation between the variables that you are using or the questions that you are using to evaluate your construct, because they are all evaluating the same construct. Okay, this is good. So when we have our Butler's test of sphericity, which is statistically insignificant, it's fine. It tells us that, okay, there is correlation between all of the variables that we are including in this particular factor analysis. Okay, then the next thing which we want to look at is the commonalities, is how these variables, the correlation between these variables, between the variables themselves. Okay, so let's say we use like 7 questions to measure reliability and 3 questions to measure responsiveness, or there is an issue. I was supposed to rename this one. It should be responsiveness 3. Okay. Okay. So let's say we want to evaluate this construct. Okay, and we should see that the correlation, because this is the correlation. Okay, this is the correlation between the different variables. Okay, we should see strong correlation. So you see a correlation of higher than 50% is a strong correlation, but this is a weak correlation. Okay, because it is less than 0.5, right? And so all of the variables should have some level of correlation between themselves. Okay, they should be correlated. There should be strong correlation, not weak correlation, strong correlation between themselves. So this is already telling us that the question that we are using in the name of reliability tool, or maybe this particular variable here, it does not correlate very strongly with the other one. So it might not be good. Okay, it might not be a good variable to consider in the construct that we are trying to measure. Okay, so let's leave that for now. We are going to get a more conclusive we are going to make a more conclusive statement on that as we continue with the data interpretation below. Okay, so what we have next here is this table on the total variance explained. Okay, what is of interest to us here is the eigens. Okay, eigens value. Eigens value. Wow. That's what is of interest to us here. And we need to have eigens value that are greater than 1. The eigens value permits us to identify the different factors that explain these variables and how we can group these variables. So what this is telling us is that we can group all these 10 variables that we have. We can actually group them into 2 variables, because only these 2 variables have eigenvalues greater than 1. So in your analysis, okay, in your exploratory factor analysis, you want the different factors or the different groupings that you should have eigenvalues that are greater than 1. Okay, so you see these 2 variables. Okay, these 2 possible groupings, okay, have eigenvalue greater than 1. And when we come here and we look at the cumulative loading, it shows us that these 2 variables explain 74% of the variation in all those 10 variables. Okay, So these two categories on their own, okay, if we categorize the variables following these two categories, okay, we are going to be explaining 74% or close to 75% of the variation between those variables. So it's already telling us that we should have two factors coming out from these 10 variables, or we should have two groupings of these 10 variables, okay, which we initially had. Okay, good. So this is the component matrix. Okay, this is our reproduce correlation. There's a very important aspect here which we need to keep in mind, and this is an assumption that we actually need to make sure it's verified, so that we are sure that our model is a good fit. Okay, we should have less than 50%, okay, non-redundant residuals. Okay, for this case we have 33%, okay, non-redundant residuals, okay, which shows that our model is actually a good fit for the exploratory factor analysis. Okay, now this is what is of interest to us right now is the rotated component matrix. The rotated component matrix tells us how the different variables should now be grouped together. Okay, so you see in our eigens value table, it told us that we can group all 10 variables into two variables, okay, into two possible groups. We can create two categories or two factors, okay, let me use the technical word that is used. We can create two factors out of these 10 variables that we have had, that we initially had from our literature. Okay, so you see, it shows us that we can group the reliability variables into one group. Okay, we can group this set of variables into one group, and we can also have another group that captures these last three variables. Okay, but if you look very closely, you see that reliability 2, okay, this variable reliability 2 is blank here because it has been suppressed, meaning that this variable, the correlation of this variable with the other variables, which is what we refer to here as the factor loading, okay, is less than 5%. Okay, if we come to the initial table here and we look at how these variables correlate with each other, we see that there is a weak correlation here. Okay, a correlation of 0.26 or a 26% correlation is a weak correlation. A strong correlation would be from 5%, I mean from 50% upward, or 0.5% or 0.5 upward. Okay, so we could already see here that our second variable does not quite correlate well with the other variables, meaning it does not capture the variability. It does not capture that particular construct very well. It's not very suitable for measuring that construct. Any variable that should be included in the way we measure that construct should have at least 5%, 50% correlation with the other variables that are used in measuring that construct. So that's already a clear indication that our second variable here, this reliability 2, is not a good fit for that particular model. Okay, now if you had many more variables, we would be able to have identify other variables that are not suitable to measure the construct that we intend to measure. So when this is the case, what we do, okay, is that we rerun our analysis. Let me close this, and we eliminate this variable in the analysis, okay, so that we get a clearer picture of the variables that can be used to measure that construct. So we come back, we rerun our analysis. Okay, we said we recognize that the variable reliability 2 does not properly describe our construct, so we exclude it. Okay, from our analysis, every other thing is the same. Okay, every other thing is the same. Extraction, every other thing is okay. Principal component, rotation, varimax is okay. Options, okay, 50%, so press that, okay, everything fine. And then we rerun our analysis. Okay, when we rerun our analysis, you would see reliability 2 is no longer included in our analysis. Okay, and it's no longer included in our analysis. When you go through, you look at the correlation of these different variables that are used to measure that construct, you see that they all have very, very strong correlation. They have strong correlation that is strong, higher than 5%. So there is good loading. They load all very well together, and we still have our this table, this total variance explained, which tells us that we have two factors that explain the two factors with two factors or two possible groupings that together, this point, you see, when we remove that variable, we first of all had 74% here, but with the elimination of reliability tool, we see that our variables now explain 80%, okay, of the variation, okay? 80% of the variation in those variables can be captured by these two factors, by these two groupings that we have, okay? We come here, we go down to our, and this was also reduced, okay? It has also reduced, meaning our model is becoming better fit, but it was already good since we had less than 50% non-redundant residual, okay? So now we come to our rotated component, okay? So this tells us that, okay, we see the different variables here. So we should have one factor, okay, that will capture reliability, okay? So then we can have one factor, one dimension, in this particular case of customer satisfaction with respect to the data that we have. We'll have one dimension of customer satisfaction, okay, that is reliability. Okay, so reliability is very important, and what this tells us is that these variables that we have here, which in our instrument will be questions, in our research instruments will be questions. So these questions that we have here are suitable for measuring reliability. So we'll put reliability, and then we'll ask these questions as far as reliability is concerned, and we know that is going to measure the reliability very well, okay? And then this set of questions also would be good for measuring responsiveness, okay? Yeah, so when you are reporting your exploratory factor analysis, what you want to do, you want to report this table, okay? Generally, when reporting factor analysis, exploratory factor analysis, we generally report this particular table. We report our Kaiser-Meyer KMO, excuse me, and we report our Butler's test of sphericity. Okay, we report these two, and we also report this rotated component metrics. Okay, this is what tells us, okay, this variable should be all grouped in this category, and these other variables should be grouped in that particular and in another category. And these different categories better explain the construct that we are trying to evaluate properly. Okay, so that's it for factor analysis, and I hope you found one or two things interesting, learned one or two things from this presentation, and of course we'll be having confirmatory factor analysis in our next presentation. Okay, thank you very much. We have come to the end of the presentation. We can now take questions. Thank you. Okay, we would strongly encourage all of our participants to use the Q&A section to forward their questions to us. Thank you very much.
There's a couple of people complimenting you on a very good presentation, Clement, so thank you for that.
Thank you. Thank you very much.
And we're just waiting for any questions from any of the attendees. It could be the case that you explained it so well that they don't have any questions anymore.
I hope so. I hope so.
If you could repeat for a student which tables to include in the research.
Which tables to include in the research? Okay. Well, the whole aim of factor analysis, okay, is to capture which variables you should include in your actual research, okay? Factor analysis is very good for pilot studies to pretest your instrument, okay? So let me just share my screen just to give you an idea of what I'm trying to say. Okay, remember when we did our initial factor analysis? Let me close this. Analyze factor reduction. Let's put our reliability too. Okay. Remember when we did this analysis, it came out clear. Oh, it looks like that has not been included. Okay. Yeah. Remember when we did our analysis, we realized that this particular variable, reliability 2, was not suitable for our model. Maybe it's a question that we asked in our instrument that is not suitable for measuring the construct that we are measuring. Okay. So maybe after our pilot study, when we've realized this, we'll just eliminate that particular question because it's not a good fit for the construct that we want to measure. And we include maybe only those questions that properly capture the construct which we are measuring. In fact, the whole importance of this is to eliminate all of those questions that do not properly measure your construct, so that you, first of all, not be overworking participants by asking them questions that are not very relevant to the construct. And also during your analysis, okay, you'll be capturing just what is essential with respect to the construct that you're measuring. Okay, so you want to remove everything that is not relevant to it. And we measure that relevance in our factor analysis by just looking at the correlation, how well a variable correlates with the other variables in the construct that we are trying to measure. And that correlation is what is referred to as factor loading. Okay, how well does this variable load with the other factors? Do they all move in the same direction? Is that correlation a strong correlation? Okay, if it's a weak correlation, meaning it is less than there is a less than 0.5, and the R value or the coefficient of correlation is less than 0.5, okay, then you should definitely not make use of it. Make use of only those that have strong correlation. And if you see, even on this table that provides us with the categories or the categories in which we can classify the variables that we are using, it captures just the percentage of it captures, in this case, 74%, because we've added those irrelevant variables and irrelevant variables. And you realize when we take away the irrelevant variable, these two factors will capture a greater part of the variance of what we want to study. Okay, and so we are interested in capturing that which is essential. Okay, and not making use in our model of variables that do not properly capture what we want to study. So the actual questions or the actual variables that you should retain for your final research should be those that have very good factor loading. Okay, and just maybe to add other reliability tests like the Converge alpha test, and I think maybe test retest also. They all measure the reliability. Okay, I mean not the reliability. They all measure the internal consistency, the internal correlation, how those variables correlate with each other. Okay, yeah, that's it. So that's basically what you are trying to evaluate when you are doing exploratory factor analysis. I hope my response is satisfactory to satisfies that question. Mm-hmm.
Okay, excellent.
Mm-hmm.
So once again, thank you for a very good presentation. And the question is, exploratory factor analysis is for quantitative research, and confirmatory factor analysis is for qualitative research. Is that correct?
Sorry, that is incorrect. Confirmatory factor analysis is still for quantitative research. Okay, confirmatory factor analysis is when you are testing hypothesis. Okay, if you want to run, if you have SPSS AMOS and you want to run SEM, okay, structural equation modeling, okay, you will first of all have to run a factor analysis. Factor analysis is for testing, confirmatory factor analysis, excuse me, is for testing your hypothesis, okay? Exploratory factor analysis is just like the initial part when you want to identify which variables to use in your instrument, okay? Data analysis for qualitative research is you be doing most of the time thematic analysis, okay? But confirmatory factor analysis is to test hypotheses. The presentation will be coming up next. That should be the next presentation, not long from now. So you get a clearer understanding of what I mean now. But exploratory factor analysis is that initial analysis that you want to run to maybe identify which variables to include to use to measure a construct, since you don't have an already existing validated instrument to measure the construct that you want to measure. I hope that answers the question.
Can you explain how to use factor analysis for a desktop review of accounting data?
Well, first of all, there are two types of factor analysis. Okay. Now, if you are trying to, it depends on the type of analysis of accounting data that you are trying to run. Okay. But if you have lots of data in front of you and you want to identify which variables, okay, best describe whatever accounting construct you want to measure. Okay, let's say you want to measure an accounting construct, maybe profitability. I don't know, I'm not an expert in accounting. And you have a set of variables in front of you, a set of indicators of profitability from maybe you've read literature and you have the data in front of you and it tells you, literature has told you, okay, you want to measure profitability, this is what you need, these measures. Or maybe you want to measure let's say the financial performance of an organization, and you have their accounts in front of you and the rest are from the literature. It says, okay, these are the different indicators that you should use. Maybe there is no established instrument. This is an example I'm using, right? Maybe there is no established instrument that you can use to measure the financial performance, but I'm sure there exists a validated instrument for doing that. But let's say you don't have that. Okay, then you have maybe a set of indicators from the literature that you've read that tells you, okay, you want to measure the financial performance of an organization. The construct of financial performance is measured using these indicators, and these indicators. You have the data in front of you, okay? So then you want to collect all of the data that correspond to those different indicators, enter them in SPSS, and then run your exploratory factor analysis and see which of those indicators is suitable for measuring, is actually suitable for measuring financial performance of the organization based on the data that you have at hand. Okay, so whatever construct you want to measure, the whole idea is whatever construct you want to measure, initially you would have many indicators, okay, or many variables that you can use to measure that construct, but then you want to eliminate those that do not correlate well with the others, meaning they are not quite relevant as the others. So you want to eliminate those, okay, and make use only of those variables, or maybe in this case, indicators that properly capture the construct that you want to measure. So yeah, that's what exploratory factor analysis basically is about. That's just what you want to do. And once you've been able to identify that, you can then classify them. Okay, you can then classify them into different categories, as in this case, we have two categories that we've come out with. Okay, you can see this is one category, and then this is a second category. You want to classify them into different categories or dimensions that you can then use to say, okay, financial performance of an organization can be broken down into these particular categories, and for each of these categories or factors, these variables can be used, or this set of indicators can be used to measure it. So, I mean, that's basically what can be done. Well, and yet I'm not an expert in accounting, so but that's the principle, and I hope my answer to the question is satisfactory. Thank you.
So the next question, I'm not quite sure about it myself, but I'll read it for you. One question for me is that there were many tables. Which ones are the most important to add to the work, or it's just a quality check and does not need to be added to the analysis?
Well, Well, in your work, you can choose to report your, especially if you don't have an already existing instrument. Let's just say in the case of your thesis, you might choose to report the results of your factor analysis, of your exploratory factor analysis. Okay, so in order to do so, okay, you report this table, this KMO and the Butler's test. Okay, and then you also report the repeated component metrics. Okay, that's when you don't have, this becomes relevant only when you don't have a well-established instrument, okay, an already validated instrument for measuring what you want to measure. But I mean, if there already exist instruments to measure the construct that you can use to evaluate the construct that is relevant to your study, then you will not need to do this, okay. But still, it's good to know, okay, because even once you even after you finish your studies at UNICAP, at some point, okay, you might want to carry out a research which might involve aspects which do not already have an established instrument for measuring. And at that point, you might want to run factor analysis to make sure the measure you are using or the indicators or the variables you are using are relevant to the construct which you want to measure. Thank you.
When is the KMO value considered inadequate? Can you please explain that again?
Yes, the KMO value is considered inadequate when it is less than 0.5. Okay, you want your KMO values to be from 0.5% to 1%, and the KMO is very sensitive to the sample size. Okay, generally when your sample size is not good enough, okay, it's too small, okay, then you would also have a very you have a KMO value that is not adequate. But your KMO value should be between 5 to 0.5 to 1. Okay, it should be varied between 0.5 to 1. When it is less, or when SPSS is unable to generate a KMO value for you, it means the sample you are using is not a good fit. Okay, you might also in your sample have some variables that are very, very, very poorly defined. Okay, or that are really, really like not good. Okay, KMO also is slightly sensitive to that. Okay, especially variables that maybe have negative correlation with the other variables. Okay, let's say I want to measure how satisfied people are with a bank. Okay, and I maybe ask them a question that is actually evaluating how dissatisfied they are with the bank. Okay, and that question is then going to have a negative correlation with the other questions. Okay, and now when you have such a case, your KMO value will not be adequate. Okay, but the KMO is just like a goodness of fit test. Okay, it's like a goodness of fit test. It shows how well your sample is good, is how adequate your sample is to measure what you intend to measure. So make sure your KMO value is between 5 and 1. Any value between 1 and 5, very good.
Excellent. Again, thank you very much, Dr. Dinda. This student has been having a phobia of numbers, quantitative data, but with this instrument, he feels that he can carry on.
Thank you very much.
More positive comments as well, which I just convey as generally people seem to be very pleased with the way you redefined the presentation.
Thank you very much.
On to the next question. So do we need to report the results of the EFA as part of the study? If yes, at what point? Should it be in chapter 3, which talks about the procedures, as this is not data analysis, but rather quality check? So the question is, do we need to report the results of the EFA as part of the study, and where?
Yeah, very, very good question. Once again, if you're using an already validated instrument, this does not really mean, it would not really be very meaningful. But then if you are still trying to validate your instrument, okay, then you should definitely report this when you are discussing your instrument, okay? you should definitely report this when you're discussing your instrument, and also aspects like batch alpha, when you're measuring the reliability of your instrument. Okay, so the exploratory factor analysis can be reported at that point. And once again, when you're reporting your exploratory factor analysis, you need to report this particular table. Don't fill up your work with so many tables. Okay, most of these other tables are just explaining the same thing from different angles. Okay, like this one is explaining the factor loading. Okay, how well the variables correlate with each other. This is just telling us that, okay, we should have two categories for these variables. This set of variables that we have, we should have just two categories. And then this one is pointing to us the two categories that we have. This one is just this table, this reproduced correlation is just a goodness of fit table. I mean, it's just a model fit table. Okay, so general, you want to report this one. Okay, this table, this rotated component matrix table, okay, because this already indicates the two components, the different components that you should have, okay, and also this table, which gives us an idea of whether or not your sample size, or I mean, whether or not the sample is a good fit for the factor analysis. But it would be a good addition to your work. Okay, some might choose not to report it, okay, but it would be a good addition to your work to report this when you're discussing your research instrument. And that should be where? Chapter 3. Yeah, chapter 3, when you're discussing your research instrument, the reliability and validity of your research instrument. I don't know if in our template it's in chapter 3 or chapter 4, whichever it is in, you should report it when you're reporting, when you're discussing your research instrument. Thank you.
Okay, and a follow-up to that question, what if the instrument has been adapted? Do we need EFA?
Now, if the instrument is adapted, generally would require you just to do the co-batch alpha, okay, just to run a basic reliability test, okay. I think there is the test retest, there is the co-batch alpha, there should be another reliability test, but any of those reliability tests, okay, once you've adapted the instrument, you can just run those reliability tests, and it will tell you real quick, okay, it will measure, and yet even the co-batch alpha value is just measuring internal correlation between the questions or the variables that are used to measure the construct. And I always would advise students, okay, when you are doing your co-batch alpha test, okay, don't group all of the variables, don't take all of the variables in your research and do one co-batch alpha test. You should do one co-batch alpha test for the variables that measure or the questions that you are using to measure maybe a particular variable. Let's say you are using, in this case, maybe 5 or 6 questions to measure reliability. Do a co-batch alpha value, a co-batch alpha test for a cron-batch alpha test. That's what cron-batch alpha test for reliability. Do another cron-batch alpha test for responsiveness. Do another cron-batch alpha test because you should be using more than one indicators to measure the variables in your research. So yeah, that's if you are actually adapting an already validated instrument, you will not use this. This is really like when you don't have any instrument and you are starting from the literature review. Okay, the literature review is informing you of what variables to include in your research, or the maybe expert opinion is informing you of what variables to use in your research. Then you want to start from here to make sure that maybe qualitative information that you have received is a good reflection of the numbers, of the quantitative, the numeric data that you're getting from the ground. I hope that answers the question.
I think so. Now, before the next question, if anybody has any other questions, please post them in the Q&A, because if there are no more questions, then when we run out of questions, we're going to end the webinar. So, next question. You have said that factor analysis is used to testing hypotheses. Is it right to say that factor analysis cannot be applied in qualitative research?
Yes, to be specific, confirmatory factor analysis is used for testing hypotheses. Exploratory factor analysis is used to reduce many set of variables to a particular category and eliminating. In fact, is for variable reduction. Exploratory factor analysis is for variable reduction, and both are statistical analysis and are not suitable for qualitative research. Confirmatory factor analysis is not suitable for qualitative research. There will be a presentation on confirmatory factor analysis not long from now, okay? And you understand what I mean. And yeah, I mean, it's a more advanced analysis, okay? And it's generally done when you are trying to do structural equation modeling. Same.
Okay. What if I adapted some questions and self-generate other questions? Do I still need EFA? It's a follow-up to the
Uh,
previous two.
yeah, well, yeah, if you're adding more questions, then you definitely really need the EFA, okay? Because those additional questions that you are bringing in need to load well with the other questions, okay? They need to correlate strongly with the other questions. Okay, so you want to include all of them so that you can get a picture of how all those factors, how all those questions or how all those variables correlate between themselves. Yeah, in fact, the basic principle is this. The basic idea is this. If I have multiple variables or multiple questions that are evaluating the same thing, okay, then there should be correlation between the responses that will be provided for those variables or for those questions that I'm using. Okay. If I want to evaluate maybe how maybe how do I call it hunger? I mean how hungry you are. Okay. There should be correlation between the different questions that are used to evaluate that. Okay. So if there is really if the correlation between the questions that I'm using to ask to evaluate that particular construct is, if that correlation is weak, okay, then it shows that those questions are not adequate for measuring what I want to measure. So even when you're adding in more questions, you want to make sure those questions correlate with those that are already established properly and make sure you have good factor loading. And once you have good factor loading, you have a very good, you're very confident that you are measuring what you intend to measure. Okay.
So there's a question where they're asking about the audio and saying that it's very low and if it's possible to retrieve this in some way. The audio is the standard setting for the Zoom webinars that we use at UNICAF. We basically do make it as loud as we can, but you also have the settings on your end, on your device or your computer, where you can increase the audio. Now, the recording of this will be posted on the Student Help Center in the VLE, and you can watch that recording and increase the audio on your end. But there's nothing we can do to change the level from this end because we've already got it on max.
Yeah.
So
Yeah,
yeah.
so, yeah, if I may add, maybe when watching the recording, okay, maybe get a set of headphones, okay,
Mm.
or connect the speakers to your device, okay, and increase the volume, and you should get good volume and should be able to understand all what we are saying. I do that. I understand the concern of these students. I've had that experience as well.
So have I.
So yeah, so by getting headphones or maybe an extra set of speakers, you can hear everything very, very clearly.
I do think the audio for the Zoom meetings is set to work through speakers more than through
Yeah,
like
yeah,
an
yeah,
open laptop
yeah,
microphone. So that could be the issue there.
yeah.
Also, this student has questions relating to interpretation of SPSS and is asking
Mhm,
where he can forward them. Now, in UNICAF, I think it will be a question of either contacting your supervisor or going back and reviewing the recordings that we've already provided. We don't, as far as I know, provide independent tuition in statistics for our students, do we? It's
mhm,
they have to either get it from their supervisor or look it up with the material previously provided, ask a question during a live webinar if that's possible, or Google it on YouTube. I know that Dr. Costas Fordio, especially in terms of the presentation he made, he did specify that there's so much information there that he simply couldn't include it all in his webinar, and that you do have to look to further resources. But we are at PhD level. This isn't undergraduate level. You should be able to do basic research by yourself without needing further guidance. That having been said, there are options. You can always email the school, you can email your supervisor, and they will guide you if they need to. The
Yeah,
thing is, for something like this, they shouldn't really need to guide you that much, not at PhD level.
yeah,
Okay, so
yeah.
that's that question done, I think. Um, and more compliments on an excellent course.
Thank you very much.
Oh,
It's
yes.
very satisfying to get those, to
Mm,
hear those words. And maybe just in continuation to what you said, Sebastian,
of
while I wait
course.
for more questions.
Hmm.
Unicat is really doing a great job making life easy for students. Okay. I discuss with students in other universities and professors from other universities, and people don't really care that much. Okay.
Mm,
Uh, yeah.
we're different.
Yeah. I mean, most of the old school guys who are making use of SPSS, for example, almost everybody is self-taught. Okay. Almost everybody during their doctoral level at some point realize, okay, I need to be able to analyze statistical data and dive into it. Just started learning, and in the process, became well established in what they are doing. On my part, for example, I had an SPSS guide, okay, with instructions on what to do and how to do. Had a very big analysis guide, and try and learn. Listen to tutorials in YouTube, as you say. Gather as much information as I can on whatever I want to do. And when I do, I compare with what others have done, and I realize, oh, I'm doing what others are doing. And so at the doctoral level, you need to be able to do this because there is no higher teaching above this. And at this point, you should be able to find the information that you need, read it, understand it, make use out of it. Yeah, the research that we do is not only to defend to do our defense, but it's an aptitude which we should have from here forward. And another important thing is that you can easily get outdated after your doctorate if you don't keep learning and if you don't keep doing research. Okay, the world is moving so fast. Okay, when I was doing my PhD, for example, there was no noise about artificial intelligence. Okay. Today, the whole talk everywhere is artificial intelligence, and if I don't update myself on that, I'm going to be I'm going to be outdated over time. That's just a very narrow example. But I mean, what I'm trying to say
Mm,
is, now henceforth, you need to be updating yourself. If you see, okay, like we identify knowledge gaps during research, if you realize that, okay, you have a knowledge lacking in this particular thing, fill it up as fast as you can, okay, and keep the ball rolling. Else, at the end of the day, not long after your doctorate, you become a doctor with just a title and very little relevant content because you're outdated. Stuff is outdated.
unfortunately, yeah, it's true. It's all moving very
Mm.
fast today.
Yeah, yeah.
Um, I don't think we have any more questions, Dr. Clement. Um, and we can wait another couple of minutes, but if they haven't come already, I don't think they're going to.
Yeah. Well, I really hope the presentation was informative and easy to understand to as many participants as possible. Yeah, I think from the feedback we've had, maybe that should be
I
the
think
case
so,
for most of
yeah.
us.
I've
Yeah.
I've done a
So
lot of statistics webinars now, and this has had one of the most positive responses so far
yeah,
in terms of how it was received. So that's
yeah.
good.
This is great. This is great.
Excellent.
Mm.
Well, thank you very much, Dr. Clement. Oh, there we go. Okay, just a thank you.
Okay.
Um, thank you everybody for attending, and we will see you at UU Stats 9, which is on the 4th of June, I believe.
Yeah. Sure.
Excellent.
Okay.
Have a good
Okay.
afternoon. Nice
Okay. Thank
presentation.
you very
Thank
much.
you.
Bye
Bye
bye for
bye.
now. Bye.